Welcome back to College Algebra. Today we're going to be looking at chapter 6.5, Logarithmic Properties. Let's go ahead and jump right in. Our verse of the day today is just one that I was reflecting about and thinking about the world of mathematics and us getting to observe these properties and not create them, but just observe them naturally happen. A phrase that I like to say a lot of times is if 1 plus 1 is true, or if 1 plus 1 is 2, then all of this is true. And as soon as we discovered 1 plus 1 is 2, everything else just fell out of it, out of discovery. And I think it's just an incredible thing that we're not making something up. I'm not giving you information that I have some secret to, but this is the mathematics of the world. And thinking about that, it made me think of this verse, which just said, I've heard all about you, Lord, and I am filled with awe by awe of your amazing works. That's in Habakkuk 3:2, and I mean, the Lord is doing amazing works amongst the Israelites in the Old Testament, miracles and signs from the sky and deep in the earth. And he's still doing amazing works in the math and the order and the creation of the universe around us. So, something to think about as we move into something as mundane as logarithmic properties. So the first property of logarithms is the product rule, which if you look at this multiplication on the inside, it seems to turn into addition on the outside. And that's really similar and actually derived from it being an inverse of the exponent, where if you remember, there's like kind of a parallel exponent rule that says we could use the same exact letters. We could say b to the m times b to the n is equal to b to the m plus n. And what you see here in this exponential property is that multiplication's on the outside and it turned into addition on the inside. And so it's flip-flopped. What used to be on the outside is now on the inside and vice versa. And so this property is one of the old properties of exponentials, just moved into logarithms. And so what does that mean? That means we can take any multiplication on the inside and break it apart into, with the same base, log base b of 8 plus log base b of k. And then technically we could do it again, because isn't 8 just the same thing as 4 times 2? And so this technically could be written as log base b of 4 plus log base b of 2, because 4 times 2 is 8. And that k is still hanging out, log base b of k. And then technically, couldn't we do it one more time and say log base b of 2 plus log base b of 2 plus log base b, a lot of writing in this section, that's okay, of 2 plus log base b of k. Oh, and then before highlighting it, 3 of those things are the exact same things. And if you have a t-shirt and a t-shirt and a t-shirt, you have 3 t-shirts. If you have a desk and a desk and a desk, you have 3 desks. So even if it's ugly, if you have a log b2 and a log b2 and a log b2, you have 3 log base 2s, or log base b of 2s. So I'm going to combine those 3 log base b of 2s and write a final answer that looks like this. We're actually going to get a tool later on that makes that a little bit faster. So if you said that's a lot of writing, that's okay. We'll make it a little bit faster later. All right, so this quotient rule says if you look at this, division on the inside turns into subtraction on the outside. And you guessed it, we have an exponential rule that this mirrors, but flipped, where we could say if you have b to the m over b to the n, so that looks like division on the outside of the exponent turns into b to the m minus n, turns into subtraction on the inside. So you see again, the property is mirrored or flipped or the opposite of what it used to be. All right, so we're going to use that property and expand this, and this one's going to actually be pretty long, so bear with me, but we're just going to do one step at a time and say that division is going to turn into subtraction. So log 3 of 7x squared plus 21x minus log 3, because that's that minus sign on the outside, 7x times x minus 1 times x minus 2. And there we go, we split up the division. Now technically there's a lot of multiplication we could split up here. So let's go ahead and try to do it as best as we can. The first thing I'm going to do is factor out something in common on this side. So log 3 of 7x outside of x plus, what is that going to be? 3. 21 divided by 7 is 3. Minus log 3 of 7x times x minus 1 times x minus 2. And now look at all these multiplications on the inside. They can all be split up as well. There's a bunch of them. And so I'm going to do them in 2 chunks. I'm going to do this left chunk. I'm going to say this is the same thing as log 3 of 7 plus log 3 of x plus log 3 of x plus 3. So there's that blue chunk getting split up 3 different ways because there's 3 different terms that are being multiplied. And a minus sign with some big old parentheses because we're about to split up something on the inside and we're going to need to subtract the whole thing, not just parts of it. And so we're going to say minus log 3 of 7 plus log 3 of x plus log 3 of x minus 1 plus log 3 of x minus 2. And that got really long really fast. But if we distribute that minus sign to that entire side, I know I can copy and paste and you might not be able to. So if we take that minus sign and we distribute it across the entire side, so it used to be a minus on the outside, now we're just distributive propertying it across the whole thing, we're going to see some stuff cancel. Like for example, this log 3 7 cancels with this log 3 7. This log 3x cancels with this log 3x. And we're left with just log 3 of x plus 3 minus what is left over. Let me highlight it so I can see it. There's one term, there's a second term, there's a third term. Minus log 3 of x minus 1 minus log 3 of x minus 2. And there's an expanded logarithm. Zoom out so you can see that whole thing at once. If you want to pause and look at that and see where everything happened, it's a lot of writing, so it might take some time to read and be like, okay, I get that part and I get that part, and that's okay. All right, let's move on and learn about a third rule. So a third rule says, look at this n and the exponent on the inside. So we have an exponent on the inside, and it turns into multiplication on the outside. So an exponent on the inside turns into multiplication on the outside. And do we have a rule kind of like that for exponents? You bet. We have the rule that exponents on the outside, so say we have b to the m raised to the n. So an exponent on the outside actually turns into multiplication on the inside. So where it was exponentiated outside of the original exponent, it's now multiplied inside. And here we have exponentiation inside of the log being multiplied on the outside of the log. So this one looks a little different because it's moving the exponent to the back end, but it still derives its root from the original exponential property. And so right here you can see a really quick way to do this is just to move that 2 to the front. You can say equals 2 natural log of x. A really fun extra little activity if you want to try it is to say x squared is the same thing as x times x. And so you could use the product rule and find the same result. So maybe if you're someone who likes to go a little extra and try something, maybe try to rewrite x squared as x times x and use the product rule instead of this power rule. All right, here we have a new natural log where, remember, this is written the same thing, or written the same way as -2 because that negative sign sends it to the bottom or to the top. It flips what side of the fraction it's on. That's what a negative exponent means. And so we just move that 2 to the front with the multiplication symbol and say -2 ln of x. And again, here's an example where you could probably use the quotient rule and get the same result. And if you want to go and try that, you could totally try to use the division rule we just talked about to hunt that down. All right, now maybe take this rule and go backwards. Send the 2 up to the top, and you get log base 3 of 4 to the second power, which is log base 3 of 16. So all in all, these rules, if they're standing by themselves, are not too complex. And so here's an example where we're going to get to do them all at the same time, and I'm going to try to take some shortcuts to show you how you can look at these problems. So the first little shortcut I would tell you is if it's on the top of the logarithm, it's going to be positive because of the product rule and it staying on the top. So multiply 2 positives and they stay positive. If it's on the bottom, because of the quotient rule, it's going to end up negative. And all of those exponents, they have to stay with the term they started with. So the 2 stays with the x, the 3 stays with the y, and the 4 stays with the z. And so using kind of that little shortcut where the top stays positive, the bottom stays negative, and the exponents stay with their respective variables, we could break this down all in one move where we said 2 log x, so the 2 stayed with the x and only the x, plus 3 log y minus 4 log z. And there we were able to do it in a lot shorter of time, just using a few little shortcuts. Once again, log properties are really important to know. So this is the natural log of x to the 2 over 3. And knowing those exponential properties will help you so much in making this an easier logarithm to evaluate. And so we're going to move that 2 over 3 to the front and just write the natural log of x and be done. It's expanded. We can't expand it more. All right, try it 8 is like the culmination of all of these all mixed up together. I'm going to let you try that on your own. There is a worked out example in the notes, so if you get stuck, you could look for a reference. But instead of me just telling you exactly what to do, really be careful with all those signs and all those symbols and all those exponents and where they stay, and see if you can work through try it 8 on your own. If you want to do it now and pause the video, that's great. If you want to try it later and get through the material, that's okay too. All right, so if you can work forward, you can also work backwards, which means that we can combine a bunch of logs into one single logarithm. And the way we're going to do that is we're just going to work left to right. We're just going to say, okay, if we have log 3 minus log 4, that's a division rule already worked out. And so technically this would be log of 3 over 4. And then I'll leave the rest of it alone for now because this is the first example we're doing instead of trying to condense it and do it all in one step. And then technically we could do that again, but this time we're multiplying instead of dividing because there's a plus sign. And so this would be log of 3 over 4 times 5 minus log 6, which that's just the log of 15 over 4 minus log 6. And then we can do it one more time. Change colors one more time. This is the division rule. So wait, I could label those. The first one was the purple one was the quotient rule. The second one was the product rule. And this last one's going to go back to being the quotient rule. But it'll be on this next line that we apply the quotient rule. And we say, if we're subtracting, we're actually dividing on the inside. And so we have log 15 over 4 times 1 over 6, or divided by 6. And so we get log of 15 over 24. Throw my equal signs there so you know where we started. And check the base to make sure you kept your base constant. It was all the common log, which is a base of 10 that's invisible. And we condensed a bunch of the quotient rules and the product rules all together. Here's an example where you need to do the power rule first because PEMDAS kind of still applies here, where you need to perform multiplication first. And so before doing anything else, we're going to take each of those multipliers or each of those coefficients and raise it to the power. So our first step before doing any combining is going to be log 5 plus log of, on the inside now it's going to be x to the 0.5 minus log 7x minus 1 plus log of x minus 1 cubed. And here's where I'll give you the kind of shortcut for this version. If it's positive, it goes to the top, and if it's negative, it goes to the bottom of the fraction. So top of the fraction, top of the fraction, top of the fraction, and negatives are going to end up on the bottom of the fraction, and that way when you have it all in one line, you can just combine it all at once. And so here we have, on the top, we should have 5 from the first one, x to the 0.5 from the second one, and x minus 1 to the third power from the last one. All divided by the only one that's going to go down because it's the only one that has a negative, 7x minus 1. And we combine those in a single log. We did have to do the multiplication rule first, but then we can start to piece these together a little faster by recognizing the positives stay on the top and the negatives go to the bottom. Give you a chance to try one of these on your own, so you can try this one. Try 11 if you want to. Maybe do a little distributive property first with that 4, so it's not throwing you off, and then it's going to look a lot like try at 10. All right, so there's one more formula in this section that's really important. We had the power, the quotient, and the product rule, but the last formula is this change of base formula, where if you notice, your calculator doesn't actually have a button for log of 0.5. And because it doesn't have a button, we need a formula that's going to allow us to type it in a calculator and figure out what is this log 0.5 of 8. 0.5 to the what equals 8. And so the formula that we have takes the base and sends it to the bottom, and takes the argument or the inside and sends it to the top. And so what we have is log of 0.5 of 8 is exactly the same thing as log of 8 divided by log of 0.5. And if you type that into a calculator and do the division for both of those terms, you're going to end up with something like, well, let's do it. So I have the log, regular log of 8 divided by the regular log of 0.5, and I got -3. I guess we probably could have done that without change of base formula, because we do know that 1/2 raised to what power equals 8, and the negative sends it to the top, and the 3 says 2 times 2 times 2 is 8. So that one we might not have needed a change of base. Oh, this is where it pays to read. It said using the natural logarithms. And so actually, we could have also said the natural log of 8 over the natural log of 5. And if you type that in your calculator, believe it not, so let's do ln, clear, ln, natural log on your calculator of 8 divided by, not inside the natural log, this is outside of the natural log, so you have to close that parentheses, divided by the natural log of 5. And so it should look like that on your calculator when you get it typed in. And it's actually, 0.5. The natural log of 0.5. So the natural log of 8, close parentheses, divided by the natural log of 0.5, close parentheses. So it actually should look like that once you put it in your calculator. Equals, and the calculator gives us -3. Meaning it really doesn't matter what base you pick for this change of base formula. The hint being there's only 2 bases in your calculator, the base of e, which is the natural log, and the common base, which is 10. So here we have another change of base problem where we would say the log of 100 divided by the log of 5. and we'd send that through our calculator and get 2.86 approximately. And that one makes more sense because 5 to the what equals 100? We don't know. We just know it's in between 2 and 3 because 5 to the 2 is 25 and 5 to the 3 is 125. And those are the 4 properties of logarithms. Thanks for watching. We're getting close to your Chapter 6 test, so I would start remembering and restudying and rewatching or practicing all of the problems you have from this entire chapter. Thanks for watching, and I'll see you next time.